any information needed, you need to add. And process can be randomly created. Okay, I will give the example here like this, but randomly create your process and the CPU amount of time. Okay, sometimes it may be the starvation, so you can adjust how to create the random. So good idea is you can use the static data first. Like instead of creating random value, you use this data, or you can make the simpler one. Then test it if you're running and apply the random value. So for example, in this case, there are 10 processes. Arrival time is here, CPU burst time here. So if the P0 is arrived with the time CPU burst time 10, okay, this is a PCB of the P0, it will be processed by the Q0, first Q. So time quantum 8, so, and the P1 is arrived. P1 is arrived, but it's still, the P1 will be processed, oh, where is it? It's a time 8. So time 8, the P0 will be terminated? No, not yet. So one round, okay? P0 is takes the, no, not that way. Arrival time is 2. This is a time 2, okay? It will take the 8 time slot. So 8 time slot is the time 10, okay? Then still it has the 2 remaining time, which means move to the Q1. Then the P1 is the CPU burst time 7 and the P2 CPU burst time 35. Arrival is a first in, first out, the Q. Okay? Then this is the state of the at time 10. Which one will get the CPU time? Q0, Q1, or Q2? Q0. Because Q0, if there exists any process, okay, Q0 always take the CPU time. This is not practical, but to simplify your problem. So we will use this approach. So yellow one, so we'll take the CPU one now, that is the time 7. CPU time is the time 7, so at time 17, it will be terminated. This one means it's a terminated, and also Q0, Q1. Which one will take the next CPU time? Q0, because there is the process, this. And once this one is done, at time 25, which one will take the CPU time? Q1. Finally, Q1, 16. So, and like this, you can use the arrow button to understand this one with the slide. And finally, it looks like this one. Okay? Then, after you finished all the process, you can calculate average waiting time and average response time. To fill up this one, also turnaround time. Okay? So this is the first project actually.
We can do any language we want.
Yes, you can use any language. And I will show you some of the example of the nice implementation. The next class. Okay. Any question? If you have any question regarding to the project, because you don't pay attention to this one, due date is the P0. The next, during the exercise lab, GA will brief more information about the project one. Then we have the 3 minutes. So, right? Let's take the quiz quickly. It's quiz 5. I don't know what happened. Very slow. Okay, so this is the code today. Please your last name first, followed by the first name. I think that we have the 40-something students. Can I start? Anyone who does not log in? Okay, let's start. This is chapter 5, synchronization, not scheduling. What is a situation where several processes access and manipulate the shared data concurrently? Okay, it's a race condition that causes the synchronization problem. Which one is not true for critical section problem? Okay. All the others are true. In case of share. You need to declare when you enter the bathroom. There are 3 requirements. Next chapter we will learn about the deadlock, the requirement. Circular waiting is the one of the requirements in deadlock. Swap can be implemented by what? So there are 3 types of solution: hardware, software, and OS. And which one is the hardware?
No way.
It's not open.
It's not working? Okay, so skip this one. There are some.
It was working.
It's working. Okay, I will ignore this one. So.
Whoa, my phone.
Okay, so then I'm going to use, this is question number what?
Number 3 or something.
So we did the 5, right? So I will check your answer, so then we'll consider. So anyway, so this is a test and set, always, okay? Same as output is the same as the log. UV need wider bandwidth. Which one is not true about the semaphore solution as a synchronization tool? Semaphore is the 0 or 1 is the mutex, the lock, and or you can manage the list of them. Okay. Binary semaphore is the mutex lock. Okay. So we will ignore after the number 5. This one is a sequence of read and write operation. To memory performed atomically. What is that? This is a transaction. Okay. Okay, so we will. I'm going to ignore the after the number 5. Okay, only the number 1 through 5 will be considered. Okay. Okay, thank you. And please submit the project on time because it's already extended. I'm not going to extend one more time. Okay, then we will see it in the next class.